In this tutorial, we are not just going to talk theory, we're going to roll up our sleeves and build something real together. Our mission is simple yet practical task manager API. Think of it like an engine behind a to-do list app. Here's what this little back-end brain will be able to do. Create new tasks, retrieve all tasks or grab a specific one by its ID, update a task, and delete a task. Let's dive right in. We'll cover installing Flask and Flask-RESTful, setting up the project structure, creating a basic Flask API app, adding API resources, explain status codes and error handling, and finally, testing our API with Postman. Let's dive straight into it. Open your code editor and let's build this together. Before we write a single line of code, let's set up our tools. Think of it like getting your ingredients together before cooking a meal. Open your terminal and run the following code. Pip install Flask, the heart of our project, is a lightweight, beginner-friendly web framework for Python. Think of it as the foundation and walls of our house. And Flask-RESTful. This is like adding smart appliances and gadgets to that house. It extends Flask and makes it way easier to build clean, organized, and professional REST APIs without getting lost in technical cluster. Without Flask-RESTful, we still have to handle things like defining HTTP methods and passing requests manually. With it, your code stays neat and focused on what matters, which is your app's logic. After installing, let's quickly confirm it works. In our terminal, type Python. Then in the Python prompt, input Flask and input Flask_RESTful. If you don't get any errors, you're golden. We're going to work with a super lean setup so we can focus on learning how APIs work, not getting lost in files and folders. Here's what our project directory will look like. Yep, just one file for now. Why? Because when you are getting started, juggling multiple files and modules can distract you from understanding how the parts of the APIs fit together. We'll scale up later when we bring in authentication, databases, and more advanced stuff. Next, create a folder, task_API. Inside the folder, create a file, app.py. Open the file in your favorite code editor, VS Code, Sublime, Replate, whatever you vibe with. Alright, let's get this engine running. Even if it doesn't do much yet, it's like turning on a brand new phone before setting up apps. Inside our app.py file, drop this in. Think of this as importing the main tool that lets us build a web server. This one helps us make clean, organized REST APIs without getting our hands too dirty in routing. Here we are creating our web application objects, kind of like initializing your game character before playing. Here, we wrap our Flask app with RESTful capabilities so it can understand things like get, post, puts, and delete requests. This checks if we are running this file directly. Here, this fires up our server in debug mode. If we make mistakes or changes, it auto-reloads and shows friendly error messages instead of cryptic ones. Now let's see if our app can breathe. In your terminal, type python app.py. If everything is fine, you'll get a 404 not found error. And guess what? That's perfect. It just means we haven't added any routes or endpoints yet. The app is alive. It's just got nothing to show you. Let's get hands-on with our first 3 API endpoints. We are going to build a /tags endpoint where we can do 2 things. Get all tags and post a new task. We'll handle both get and post requests with a single endpoint, but each method will do something different. Let's dive into the code. Here we're using an in-memory list to store our tags for now. Think of it as a simple placeholder. Eventually, we'll replace this with a database, but for now, this gets the job done. Now let's create our first resources, which handle requests to the /tags endpoints. Here, this is a special kind of class that Flask-RESTful uses to define our API endpoints. Think of it as a controller in other web frameworks. This method handle gets requests. When someone makes a request to /tags, we'll return all the tags in our lists. Simple, right? Here, we're sending back the list of tags in a dictionary, and 200 means everything went well. This method handles post requests, which means when someone wants to create a new task, we will handle that here. This helps us validate and get the data sent by the user. This line says, if it's missing, let's show the user a helpful error message. This actually pulls the data from the request and validates it. If the title is missing or wrong, it will raise an error. Then here, we build a tags dictionary. Each tags will have an ID, a title, and a done flag, which is set to false by default. Adding the tags, this will add a new tags to our list. Finally, we return the created tags with an HTTP 201 status code, which means created. Now that we've defined the resources, we need to register it so Flask knows to use it for /tags endpoint. Let's try it out in Postman. You should see the new tags added to our list with an ID of 1. Awesome! We are really getting a hang of this RESTful API stuff with Flask-RESTful. Let's zoom in on that get method one more time and make sure everything is crystal clear. So let's retrieve a single tags by its unique tags_ID. We're looping through the tags list, checks if any tags ID matches the tags_ID provided in the request URL. If found, we return the tags as a JSON response with HTTP status 200 OK. If not found, we return a message saying tags not found and HTTP status 404 not found error. Let's say we have these tags. ID1, title, do groceries, done, false. ID2, title, finish project, done, true. If someone makes a GET request to /tags/2, the API will respond with this. Then if the request tags/5, which doesn't exist, the API will reply with this error, tags not found, and the HTTP status will be 404. Clean, clear, and reliable. This is how RESTful APIs typically handle item lookups by ID, and you have nailed the pattern. Alright, so now that we've got our get method working, where you can grab a specific task by its ID, let's step it up. What if we want to update a task? Maybe you want to change its title or mark it as done. That's where the put method comes in. Let's build it together. So when someone hits our API with a put request, they are basically saying, hey, I want to update this task. But how do we know what they want to update? That's where the rec pass comes in. Here we create a parser. Then we tell it what kind of data we are expecting. In this case, a title and a done status, like this. Now when the request comes in, we grab whatever data it has. Imagine someone sends in this JSON. Now the tags will look like this. Here, we loop through our list of tags. If we find the one matching the task_ID the user sent, we move to updating it. Here, we only want to update the fields the user actually sent. Maybe they just want to update the done status and leave the title as is. So here is a cool trick. This loops through everything in args, only picks out the items where the value isn't null and updates the tags with those values. Pretty slick, right? Then we return the updated tags with a 200 status code. Here, if we don't find the tags with that ID, well, we politely let the user know. Alright, my friend, we've learned how to get a tags and update a tags. Now, what happens if a tags has served its purpose and we just want to get rid of it? Yeah, we need a delete method. Let's build that super clean and quick. So when someone hits our API with a delete request, they are basically saying, hey API, wipe out the tags with this number for me. And our job is to find the tags and remove it from the list. Well, here, remember our tags list lives outside the function. And if you want to modify a global variable from inside a function, you need to tell Python you're about to mess with it. Otherwise, Python thinks you're just making a new local variable called tags. Here, we are looping through every tags in our tags list, keeping only the ones where the ID doesn't match the tags_ID we are trying to delete. In other words, keep all the tags except the one I'm asking you to delete. Once we are done deleting, we send a nice friendly response back. And the 200 means, hey, everything went fine. And the message just lets the caller know we handled the request. And boom, that's our delete method done and dusted. Alright, so we've got our tags resources all set up. It knows how to get, update, and delete tags by their ID. But right now, Flask-RESTful has no clue where it should use these resources. That's where this line comes in, app.add_resources. Think of this as giving your API directions. You are basically saying, hey Flask, anytime someone makes a request to Flask/some number, call the tax resources to handle it. This is a placeholder. It means this part of URL should be an integer, and I will call it tax_id inside my code. So if someone sends a request to /tax/5, tax_id will be 5 in your get, post, or delete method. Without this line, Flask wouldn't know where to route requests. It's like building a house but never giving out the address. No one can visit because they don't know where to go. By registering the resources with this line, you are saying, yo API, here is where people can reach my tax-related endpoints. Now that we've built our endpoints for individual tags, let's give them a spin and see them in action. Let's say you want to retrieve the tags with ID 1. Here is how you do it. If the tags exists, you see it neatly printed out. If it doesn't, you would get a friendly message, tags not found. If you don't have a tags with the ID yet, you would want to post one first using the tags/tags endpoint before trying this. Alright, let's pretend you made a typo or need to mark a tags as complete. To update the tags with this ID, you will get the updated tags back in the response. And if you feel like cleaning up, let's delete the tags with the ID. If everything is wired up right, you would see tags deleted. If you try to get that tags again, you will get a tags not found message. You can try adding a new tags, updating it, and then deleting it. Once you get the hang of this, you will be unstoppable when it comes to REST APIs. Alright fam, if you enjoyed this tutorial, learned something new, or just love seeing clean, powerful APIs come to life, smash that like button. It really helps the channel and tells me you're vibing with the content. And hey, don't forget to hit that subscribe button so you never miss a new drop. More hands-on, beginner-friendly, and serious cool coding tutorials are coming your way. Trust me, you don't want to miss what's next.